before we move to the DEVS coupled model, let's look into one case study of the DEVS atomic model. So here, DEVS atomic model is given in the diagram format and is being called a soldier model, right? And the soldier model has a stage. How many stages? 1, 2, 3, 4 stages. 4 stages, and the how many inputs? 1, 2, 3 input event. And 1, 2, 3 output events. And let's interpret this diagram now. So here, the soldiers are in the maneuver state. So soldiers are moving. And now there is a transition. And one transition is what? One transition is once is time advance of the movement, defined as TM, is being done, completed, then it will say out loud to the outside world environment that, okay, I finished the move, and it will create the maneuver move result. And then the state will be turned into what? The detection state. So it means that the soldier was moving, and moving is done, and looking around like this. Looking around, detection, and there is a time, how much time that soldier will spend to detect the nearby enemy, and then the time is done, right? Then time is done, detection scan will come out, and then move again. Move, move, right? It's like a robot, right? So maneuver, detect, maneuver, detect, maneuver, detect. If there is no outside interrupt by the input event. And now here, if maneuver, in the maneuver state, there is an input event of engagement damaged, okay? So outside damage is coming in. And if that damage is bigger than a certain survival point, okay, then it will go to the inactive dead state. So this dead state, inactive state, will have infinite time advance, right? So then we explain this external event. So someone is shooting at me, and it is going to be over the amount of damage that I can endure, then I'm going to be in the inactive state, right? Right. And also, when I was in the detection state, if detection event occurs, and in this state, outside the detection event coming in as a query, that will make what? External transition, right? External transition to engagement. I saw the enemy, and I'm moving my state to the engagement, right? Engagement. And then after that, I'm preparing my attack with the time t, right? And then I'm shooting after time t with this damage attack output event, and that will be the output event, right? After this time, then I'm looking again. Oh, still there. Event engagement state. After time t and output engagement attack output event, and then coming to the detection state, and then still there, and engagement output, and then detection again. Once there is no further detection event coming in, then time advance can be completed, moving again. That's this DEVS atomic model design result, right? So these are the inputs of X. These are the outputs of Y. External state transition functions, internal state transition functions, right? So these are the things that you have to specify as a DEVS atomic model and also can be represented as diagram, right? And finally, don't forget the time advance function. Right, I already explained the soldiers model's behavior, right? Modeled by the DEVS atomic model. Anything strange? This model, a soldier can maneuver, detect, engage, and also being idle after being dead, right? However, the problem is that a soldier can behave only one action at a time. Is this realistic? Of course, in the real world, the soldier will be running at the same time looking and at the same time shooting, right? So it means that this maneuver, detection, engagement, these can be simultaneous behavior. However, in the systems model, given time t, a system can only have what? A single state, all right? That's the problem. Given certain time, a system, whole information of that system should be represented by a single S. So here, S is defined by the maneuver, detection, engagement, right? So these three states cannot happen at the same time because given time, it could be either maneuver or detection or engagement. So that this model cannot be realistic in terms of simultaneous behavior. Right? There is a time advance function, right? If time passes out, if time is being passed, the model fires an internal transition function. So after the time, model will call the internal state transition function like this, and like this, okay? And move to the appropriate state. So after all being done, then move to other states, right? That's the reason why that a certain state can exist just a single time. And furthermore, how to develop this model to be further sophisticated to support such kind of simultaneous behavior, which is definitely needed in terms of the simulation. In that case, we need to have a hierarchical model. We have to model not as a soldier, but as a legs, eyes, and the arms and hands. So that arms and hands will be shooting, eyes can be detecting, legs can be moving. And now it becomes the problem of hierarchically composing multiple models. And that now it's time to study DEVS coupled model.